In this video, we're going to talk about the types of waves that sound is. So as a review from last unit in waves, we said that sound was both longitudinal and mechanical. So now we're going to look more specifically at why. So first, how is sound created? So down at the bottom I have a little animation of a tuning fork, and so we're going to play with these in class as well as part of a lab. But what you should notice is that as the tuning fork moves, so as it's vibrating back and forth, it compresses the air that's right beside it. This is how we get the compressions and the rarefactions that we see as part of a longitudinal wave. This is what we hear as sound. So the compressions created hit our eardrum, causing our eardrum to vibrate, and all those vibrations are then interpreted by our brain as sound. So first, sound has to be produced by a vibrating source. So in this case, it's a tuning fork. Right now, you're listening to a speaker on your computer, and that speaker is causing vibrations, which then cause compressions in the air. Whenever I produce this video, I created compression, so a vibrating source would be my vocal cords. So my vocal cords vibrated, causing the air to vibrate, creating compressions and rarefactions. So, vocal cords, guitar strings. If you've ever seen a guitar string plucked, it causes those vibrations as well. And speakers, you see them moving in and out, causing vibrations, so it compresses the air in front. The vibrating material sends a disturbance, and the disturbance is those compressions and rarefactions, and the frequency of the vibrating source equals the frequency of the waves produced. So a 512 hertz tuning fork will create a sound wave in the air at 512 hertz. Everything will be equal. So sound waves are longitudinal, which means that you create a vibrating source which gives you compressions and rarefactions. And sound is also mechanical, which means that it requires a medium. And so in my little picture here, it says a sound produced by the bell cannot be heard since sound cannot travel through a vacuum. So this is a vacuum chamber. This is one of the demos that you can actually see done in class in this unit. So mechanical means it requires a medium. So sound can travel through all three states of matter: solids, liquids, and gases. And the speed depends on the medium. So hopefully we remember this from last unit. The only thing that changes speed is the medium. So, since sound is mechanical, which phase is sound the fastest in? Well, since it requires a medium, it's probably going to be fastest in the one that is more compressed. So the one that's tighter together so it can go particle to particle. So it's fastest in a solid. And so what does that make it slowest in? Well, to have speed, it'll be slowest in a gas. But the slowest speed you can have is 0, which would be a vacuum. So sound cannot travel through a vacuum because if you think back to that tuning fork that you saw vibrating, if there's nothing around that tuning fork, then nothing can compress. So there can't be sound in a vacuum because there's nothing to compress to create the sound waves that we hear.